Okay, so last time we talked about how to make solutions, and then we went into the lab and actually played around with how to make those solutions. And I told you that we were going to do another lab, and so that was just kind of a preparatory thing. And I originally wanted you to create a lab write-up for just doing that. But I've decided now that what we're really going to do is just incorporate what we learned last time into this second lab that we're going to start talking about today. Okay, so again, we have these two different techniques and for making solutions. And how many of you weren't here last time? Was it just Liana? Okay, so you've got a good person right next to you that can help you know what's going on related to these solutions, and I'm sure she'll share her notes with you. I didn't give a handout for that, so I just had people take notes. Oh, and by the way, you're going to need some new notes here. So we just pass out a couple more sheets of paper here for everybody. Oh, you weren't here last time either. You are. And you weren't here for part of it. So who would be willing to let me borrow their notes and go make a copy of them in a little while so that the three that weren't here last time can have a good set of notes? Who feels like they really took good notes? Did you take good notes, Jackie? Huh? Does it? Who took really good notes that are neat? Okay, so I'll make a copy of those, and I'll give you three a copy of those later on so that you can make sure that you understand what we're doing here. So here's the scenario. Okay, here's the scenario. We're going to be a chemical company. So you might want to write some of this stuff down. We're a chemical company that one of the things we do is makes yellow pigment for paint. Okay, we're a chemical company that makes yellow pigment for paint. Okay, now in real life, this particular pigment's no longer in use because it's got lead in it. But we don't really care. This is just kind of a scenario that we're going to be working with. So we're going to be a chemical company that is going to make yellow pigment for paint. And we're going to do this using something called a precipitation reaction. We're going to use a precipitation reaction. And we've talked before about the idea that when I mix some solutions, some things that are dissolved in solution, when I mix some of those solutions, it may be that parts of the solutions that are dissolved, when they get together, they can no longer stay dissolved because those two parts are not going to are not going to stay dissolved because they don't have their solubility is less than what the solubility of the two main solutions are. So they come out of solution, they undissolve, okay? So this substance undissolves, and in this particular case, this substance that undissolves is going to be this yellow pigment that we want.
Dr. Marshall?
Yeah. Okay, so just to the office. Okay, thanks. Bye-bye. Brighton, apparently you're going to get checked out. I don't know if you do that or not, but can I keep your notes?
Yeah.
Okay. For that. And you can just set them on the table in front of you there, and I'll get them. Thanks. Okay, so we're going to use something called a precipitation reaction. We said the idea of precipitation was like rain falls out of the clouds, or we see rain precipitating out of the clouds. This undissolved material, this material that undissolves, is going to just magically fall out of the solution and appear. And so we're going to find out that the precipitation reaction, and I'm going to write this precipitation reaction for you here, is going to be made of these substances. So I'm going to have something called, oops, wrong substances. Oops. So we're going to have a substance called lead, so Pb acetate, and the acetate ion is a polyatomic ion, C2H3O2, and I've got two of these polyatomic ions, and each one is going to have a charge of -1, which means that lead has a charge of +2 here. So this is an ionic substance, but it does dissolve. This solution, or this dissolves, so we'll have a solution that's dissolved. And then we have another substance called potassium iodide. And iodine has a -1 charge, and potassium has a +1 charge. And these are going to react. And one of the things that you'll come to learn is that if I have two ionic compounds that are reacting together, I have an ionic compound here and I have an ionic compound here. If I have two ionic compounds that are going to react together, the metal or the cation of each compound is going to switch places. Okay? So it's going to be that if this actually causes a reaction, these two things will switch places. And because the lead replaces the potassium with the iodine, and the potassium replaces the lead, we're going to call this a double replacement reaction. Okay, so this is a double replacement reaction. And what we're going to get is lead iodide then. If lead switches with potassium, it's going to now be paired with iodine. And iodine is going to have a 1- charge as it does over here, but lead will have a 2+ charge as it does in the reactant, and so I need 2 leads, or 2 iodines, right? So in order for me to say that this can be a correct formula, I have to balance the equation. So 2 times -1 gives me 2 negative charges, and I have 2 positive charges to balance that. And then we're going to have potassium, which again has a +1 charge. And since acetate has a -1 charge, I don't need 2 of them for potassium. I just need 1, C2H3O2, and that has a -1 charge. So the acetate ion and the potassium ion are balanced, but now I have to balance the chemical equation. Okay, now I have to balance the chemical equation. I've got 2 acetates over here, but I've only got 1 acetate over here. And I can't put a subscript 2 behind it because that would mean I would have 2 negative charges instead of 1 negative charge. So those of you that have balanced chemical equations before, what am I probably going to need to do to make it so that I have 2 acetate ions on both sides of this equation? Yeah.
Put parentheses around the whole thing with a 2 in front.
Okay, but I don't need to put parentheses around the whole thing. I'm just going to put a 2 in front. Okay, and if I put a 2 in front, that means that I multiply both of these things by 2. So now I have 2 potassiums and 2 acetates, but what I have is 2 potassium acetates, right? But I don't need to put parentheses around it to indicate that. Just the fact that I put the coefficient in front of the whole thing means that I have 2 of these. 2 of these. Okay? And so now I have 2 potassiums on this side, though. And I only have 1 potassium here. So to balance that side of the equation, I'm going to need to put a 2 in front of the potassium iodide. So let's take a survey here. I have 1 lead atom. I have 1 lead atom here. I have 2 acetate ions here. And because of this 2, I have 2 acetate ions here. I have 2 potassiums here. And I have 2 potassiums here. And then I have 2 in front of this whole thing, so that also means 2 iodine atoms. And I have 2 iodine atoms here. So everything is the same on both sides of the equation. Okay? And now this is completely balanced, and this substance right here, this potassium iodide, is my yellow pigment. Okay? This is my yellow pigment. Okay, so this is our product. We are going to make this yellow pigment. Okay? Now, before we can do this, I need to know how many grams of this stuff I need to use, and I need to know how many grams of this stuff I need to use. Okay? And we've talked about how to find a number of grams. We've talked about molarity. These are going to both be solutions. Okay? I'm going to make a solution of this, and I'm going to make a solution of this, and then I'm going to mix them together, and I will form this, and it will precipitate out into the container, and then this potassium acetate will still be in solution. Okay? Now, one thing that we can do to help us know more about this is that we're going to say this is a solution and this is a solution. And the way that we say that these things are solutions is to put the letters AQ after it. If I put the letters AQ after that, what do you think AQ might mean? Any ideas? What do we also say about water?
Aqua.
It's aqueous, right? Okay, so we're going to use this as an adjective. We're going to say this is aqueous. Or you don't need me? Okay, so we're going to say this is aqueous. Okay, so that means that it's in solution. We're also going to say the same thing about that. It's aqueous, it's in solution. But to indicate that this is not aqueous anymore, it precipitates out, it's a solid, we're going to put an S there for solid. And then we're also going to say that this is aqueous. Okay? So now we've got an equation here that tells us everything we need to know about our product. Right? The thing that we're going to create. Okay? So what I've said then is we need to figure out how am I going to go into the laboratory and make this stuff. Right? How am I going to go into the laboratory and make this stuff? Okay? So we're going to make these two solutions, and you learned two different techniques for making solutions, right? You learned that we can make a solution by making it in something called a volumetric flask, and you also learned that we can make a solution by using something called a graduated pipette. Okay? So we're going to make this solution using the volumetric flask method, and we're going to make this solution using the graduated pipette solution method. Okay? So that's going to be part of this. But before we do that, again, we need to know how many grams we're going to have. Okay? How do I find out how many grams we're going to have? And let me switch to a new screen here. Let me save this so I know what we're doing. So, chemistry. Okay. Now, remember the way that we figure out the number of grams. So, one of the skills I need you to be able to have, and we've already talked about this, is I need you to be able to go into the lab and figure out how many grams to get out of the container. And the way that you're going to do that, the way that you're never going to forget how to do that, is to remember I only have one formula. I only have one formula that I can use to tell me about how many grams I have. So remember, grams equals what times what?
Molar mass times moles.
Times moles, right? Molar mass times moles. What's the molar mass of the substance, and how many moles of it do I need? Okay, how many moles of it do I need, and what's the molar mass of the substance? If I know I have 1 mole and I know the molar mass is 50 atomic mass units, or 50 grams per mole, I multiply 1 mole times 50, and I need to measure out 50 grams. Okay? Now, you're thinking, well, so far I could probably figure out the molar mass. I'll give you the molar masses of these substances, but I don't remember how I'm going to get the number of moles. Okay? Now, if you forget this formula, please remember molar mass equals grams per mole. Mass in 1 mole, grams per mole. Mass in 1 mole, grams per mole. So if I want to find grams, all I have to do is multiply both sides of that equation by moles, okay? So you should never, ever, ever forget how to find grams. Ever. because you've got this formula, and it's so easy to remember. Molar mass, mass in 1 mole. It tells you what it is. Mass in 1 mole, grams per mole. So you can always know how to find the number of grams. The problem is I need to be able to find the number of moles now as well. Okay? So we remember that we have a formula for molarity. Molarity equals how many moles in 1 liter of solution. How many moles in 1 liter of solution? And molarity tells you this too. Molarity. Okay? Molarity. Moles per liter. So since I can't use this formula to figure out how many moles I have because I'm already using this formula, I can use this formula to find out how many moles I need. And all I have to do is multiply moles, or moles equals molarity times liters, okay? And that means that I'm going to have to give you the type of solution I want you to create. I'm going to have to say for lead acetate, I'm going to have to say for lead acetate, I want you to create 0.100 liters of a 0.1 molar solution. Okay? I need you to create 0.100 liters of a 0.1 molar solution, right? And I say 0.1 molar because this is 100 milliliters, and 100 milliliters is 0.1 liters, right? It's 100,000ths of a liter. So I want you to be able to create a 0.1 liter of a 0.1 molar solution. Okay? So all I need to do then is say I've got a molarity of 0.1 moles per liter. I need you to use units, right? 0.1 moles per liter times the number of liters I have is 0.100 liters. So what's 0.1 times 0.1? It's 0.01. So I need 0.01 moles. Okay? And you're like, okay, so now I can do this. I can go back up here and I can say I need 0.01 moles. And I told you I would give you the molar mass of lead acetate, and it is 379.34. Let me get rid of this. .34 grams per mole. Okay, and so if I want to know how many grams that I'm going to need, all I need to do is multiply this by 1 and move the decimal place over 2 spots, right? If I want 1/100th of that, and I need 3.79 grams of lead acetate. Okay? I need that many grams of lead acetate. Okay? As far as the other material, the potassium iodide, remember that we said that lead acetate plus 2 potassium iodides react. Lead acetate plus 2 potassium iodides react. Okay, so this would tell me if I have 1 mole of this, I need 2 moles of this. So my chemical equation tells me everything I need to know. Sorry about that. My chemical equation tells me what I need to know. If I have 1 mole of this, I need 2 moles of this to complete the reaction. So if I have 0.01 moles of potassium iodide, if I have 0.01 moles of potassium iodide, how many moles of lead acetate, how many moles of potassium iodide do I need? If I have 0.01 moles of this, how many moles of this do I need?
0.01.
Well, don't I have to use twice as much?
0.02.
So I'm going to need 0.02 moles. Okay, so that's how these chemical equations work. I can say this is either 1 molecule of this and this is 2 molecules of this, or I could say this is 1 mole of this and this is 2 moles of this, or I could say this is 0.01 moles of this and this is 0.02 moles of this. Okay, now I want you to complete the same calculation, although you could just use this and say, well, I know if I needed 0.01 moles of this, then I must need 0.02 moles of this. But I want to work through the same calculation for potassium iodide, just so that we can be complete about this. If I want to know how many grams of potassium iodide I need to say moles times molar mass, just like I did with the lead acetate. And then I'm going to need to say moles equals molarity times liters equals, and so I need a 0.2 molar solution. So I need 0.100 liters of a 0.2 mole solution. 2 molar solution. And so you're going to say, well, my molarity is 0.02 moles per liter, and I have 0.100 liters, so that means I need 0.02 moles potassium iodide, 0.02 moles of potassium iodide, and the molar mass of this is 166.01 grams per mole. So if I multiply 0.02 times this, I'm going to get 3.32 grams of potassium iodide. Okay? So that's the routine. Anytime I say you guys need to go into the lab and you need to create this many liters of this molarity of a solution, you have to be able to figure out how many grams that you go weigh out on the balance. Okay? That's the point of this part of the lab. Okay? So that's another piece of information that you'll need to be able to complete this lab. Do I need to leave this up here for a little bit more time so that you can make sure that you have all this written down? Okay? Please make sure you understand this, because I'm going to need you, when you create your procedure for this in your write-up, to be able to explain back to me how you find the number of grams of solution, or to put into a solution. Okay? Now, I'm not just going to leave you all hanging and make you do all of this write-up stuff by yourself. We'll go through all of this in lab once we finish this again, or in a class once we finish this again, to make sure that we all have a similar type of write-up. But I am going to ask you, when you create your procedures for this, that you use your own words to describe, I did this, 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 and this to find the number of grams. I did this, 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 and this to find the number of grams. Okay? So, any questions about this? Again, you only know one formula to find the number of grams. There's no thinking about it. You don't have to know a complicated way to solve this kind of a problem. You only know one formula to find the number of grams. So you write that formula down and you say, okay, now I need to know the number of moles. And you know another formula other than this one to find the number of moles. And I will always give you this information, okay? So you won't have to go find something else again. I'll always give you this information. So you'll be able to figure out the number of moles, and you can plug that back into this equation, and I'll either ask you to figure out the molar mass on your own, or I'll give you the molar mass. The molar masses of these things are on the containers, so you can get it from that. Okay? And then you figure out the number of grams to make that solution. And then you make that solution. Can I go to another screen here now? We all? Okay. So let me save that. Okay, now the other piece of information, I already showed you how to make solutions, and you've got notes of your own on how to make solutions. The other thing I need you to be able to do is, once we create this precipitate, how do I find out how many grams that I actually have? And remember, once again, and let me write this equation down again. So I've got lead acetate, C2H3, O2, 2 plus 2 potassium iodide gives me 1 lead iodide plus 2 potassium acetates, C2H3O2. Okay? Now, because I'm a company, we want to create a product. If I use a number of grams of this and a number of grams of this, I want to know how many grams of this I'm supposed to get. How many grams of this I'm supposed to get. Why might I want to know how many grams of that I'm supposed to get? Yeah.
So you can sell the same amount every single time you get the same amount of money.
Okay, or what if I only get about half of the amount of stuff that I'm supposed to get?
Then it wouldn't look right.
Okay, well, it would work right, but I just wouldn't get, well, it didn't work right, but wouldn't it make sense that I don't want a procedure that's only going to give me 50% of what I'm supposed to get? Maybe I need to say, I need to figure out a different way to do this. Okay, so if I'm in a company, one of the things that I want to do is be able to see how effective is my process, how effective is this way of getting that pigment. If it's not very effective, then I need to do something else. Okay, what do I call the amount of stuff that I get out of a process? if I got 70% of the stuff that I'm supposed to get, I have a 70% what? What might be a term that would describe a 70%? Think of business terms. I have a 70%.
I want to say income, but that's probably not right.
How about yield? I have a 70% yield. If I get 70% of what I'm supposed to get, I would have a 70% yield. So we're going to use this idea of yield to say, this is my goal. I want to figure out what the yield of my process is. Okay? So if I want to figure out how many grams I'm expecting, I can look at my chemical equation again, and I can say, if I've got 0.01 moles of this,
Marshall,
yeah,
what does that say to the right?
yield,
Yield.
Y-E-L-D, Y-I-E-L-D, yield. If I react 0.01 moles of this with 0.02 moles of this, because I have a 1 here and a 2 here, if I start with 0.01 moles, I should use 0.02 moles. How many moles of this stuff should I get? What's the equation tell me?
0.03.
Okay, what's the number in front of this? There is no number, so it's a 1. So if I react these two things together, my equation tells me I should only get one of these things. Okay? I should only get one of these. So if I react one of these with two of these, I get one of these and two of these. It won't always work out that I get the same number of things on both sides. Okay? If I react one of these with two of these, I should get one of these. Or if I react 0.01 of these things with 0.02 of these things, I should get 0.01 of those things. I don't really care about this stuff because I don't want any of that. That doesn't matter to me. I want this stuff. Okay? That's what my equation tells me. That's the purpose of the equation. It tells me if I react this with this, I form this and this. And that's why we balance the equations, so that I can tell if I have one of these and two of these, I get one of these and two of these. Okay? If I have one of these and two of these, I get one of these and two of these. Okay? And that's always going to be the case. You always look at these coefficients to tell you how many of these things you get. So if I start with 0.01 of these and 0.02 of these, I get 0.01 moles of this. Can I use this to tell me how many grams I'm going to get?
Yes.
That's my goal, right? I want to figure out how many grams that is. Remember again, grams equals moles times molar mass. And in this case, that's going to be 0.01 moles. If I use 0.01 moles of this and 0.02 moles of this, I expect 0.01 moles of this. But now I have to figure out the number of grams in 1 mole of lead iodide. Let's just look that up. Oops. Don't want that. So instead of just figuring it out, I'm just going to look it up. 461.01 grams. So 461.01 grams equals, so I'm just going to move my decimal place over. So I'm going to expect
So how much was it?
461.01. So I'm going to expect 4.61 grams. Okay? So, and let's just use an example here for yield. Example of yield. I expect 4.61 grams. I got 3.69 grams. How am I going to figure out what my yield is?
You divide it.
I'm going to divide it, right? So my yield, my percent yield, is going to be 3.69 grams divided by 4.61 grams. 3.69 divided by 4.61 equals 0.8. And I'm going to multiply that times 100 so I can get a percent, right? So my yield is 80%. And that's actually pretty good. If I did that, that would actually be a pretty good yield. Okay? So you're going to have to, in this laboratory, show me how to calculate the yield. Okay? You're going to calculate the yield of what you got. Okay? So I'll wait for another minute or two for you to finish writing this down. I expect this, and I got that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Can I go ahead and put another screen up? You good, Kate?
Yeah.
Okay. Anyone else writing? Okay. Save.
I'm just gonna box around.
So the last thing I need to figure out then is how do I find out how many grams I got? How do I recover the precipitate? How do I recover the precipitate? Okay, and here's what we're going to do. First of all, does anybody have any guesses as to how we might get that solid particle stuff that's in the solution, that's mixed in the water, out of the water? How might I do that? Yeah.
Maybe cool it down.
Okay, I could cool it down, and that's an interesting thought. How would that help me separate the particles from the water?
I guess that wouldn't work. I was just thinking because heating it up dissolves it.
Sure. Okay, so you're correct, but we've already got the solid out, so what I want to do is separate the solid. What do you think, Devin?
You use the little filter thing.
Okay, so we're going to use a filter, right? And I've changed my mind about what type of a filter I want to use, and I'm going to show you what I want us to do here. So we're going to use a filter, okay? And the way that we're going to do this is we're going to have a funnel, and we're going to have a piece of filter paper in it. Okay, so we're going to put a piece of filter paper in the funnel, and we'll pour the solution in there, or we'll pour the mixture in there, and then we'll collect the fluid that comes out of it into a beaker, and we'll throw that away. But hopefully everything that I get should get collected in the filter here. Recovered pigment. Okay, so I'm going to show you how we're going to do that. And I will have cut these out. It's cheaper to buy the filter paper in large sheets like this and then just make the filters, so we do that. So, but so when you get yours, it will be in a circle. I'm not going to make you waste time cutting these out. You'll have a circle of filter paper. You'll fold it in half. You'll fold that in half again. And you'll fold this in half again. And then you'll fold it in half again. And that creates kind of a cone-shaped thing that looks like this. And that fits nicely into the funnel, and it'll be a little bigger than this, okay? And you'll pour the solution into this and collect the stuff that we don't want in a beaker, and then this will contain the pigment that you want, okay? Now, somehow I managed to get a little hole in this. If you get a hole in your filter paper like that, you can't use it, because then the precipitate will go through it as well. So one thing to be aware of. But I want to use this to collect that. But after I collect that, this is all still going to be wet, right? It's still going to be a little moist. It's going to be damp. It'll be like I've collected a bunch of yellow mud on here, and it will still contain water in it. And that would increase the weight of the material, or the mass of the material, if I did that. So I'm also going to have to take this, and we'll put these things in an oven to dry them, okay? So we'll take the filter paper, and put that into an oven to dry it. Okay, and then once it's dry, we'll take the mass of the whole thing, and we will previously have taken the mass of the filter paper. So mass the filter paper, collect, sample, dry, and then mass, dried, sample. Okay? And then I'll just subtract the mass of the filter paper from the dried sample, and that will tell me how many grams I got. Okay? So this is exactly the way that you would go about developing a procedure for some kind of industry. Okay? You would do this kind of a thing. You would experiment with it. You would play with it for a little while and figure out which of these things is going to, how you do this is going to work the best. And this would be how you figure out what the percent yield of your product is going to be. Okay, so this has a lot of application to a lot of things in the real world. Okay, so here's how this is going to work. You've got these these sort of instructions here. I'm going to pull up one more screen here. Okay, and here's what we're going to do. We're going to have, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students, 12 including Brighton. I'm going to say we're going to have 3 teams of 4 to 5 students. Okay, and I will select, when we come to class next time, I will select leaders, assign team members. Okay, so I'm not going to give you a choice in this. I'll select leaders and assign team members. So we'll have 3 teams and then 3 sets of teams. And what I will need you to accomplish is a procedure. You're going to have to create a procedure, and you know what step 1 and step 2 are, right? You know safety
Yes.
and materials. Okay, safety and materials. And then the third, you're going to have several headings here of other things that you need to do. A procedure for how to determine grams used. Okay, so I want you to write out several steps telling me this is how I figured out how many grams we used. And it may take 2 steps for one person or 4 steps for another person. You'll each have your own, or for teams. So as a team, you'll determine what these steps are going to be, okay? How to determine grams used of each substance. Because you're going to tell your other divisions of your company how to do this, right? You want to communicate this to the rest of your company so they all know how to do it too. So I need, the first part of the procedure is going to be how to determine grams used of each substance. Okay, that'll take several steps. The next heading is going to be how to create a solution with a volumetric flask. Okay, how to create a solution with a volumetric flask. And you'll make the first solution with the volumetric flask. Your third section of the procedure will be how to make a solution with a graduated pipette. Okay, and so the solution I want you to make with the volumetric flask is 0.100 liters of 0.1 molar lead acetate. Okay, and you've already got the calculation for that, right? It ended up being 3-point-something grams. Okay, how to make a solution with a graduated pipette. I want 0.100 liters of a 0.2 molar potassium iodide solution. Okay, and you're going to make that in an Erlenmeyer flask. Okay, so you're going to have to figure out how to use this to make 100 milliliters of a solution of potassium iodide in the Erlenmeyer flask. Okay, remember, you're just going to put the number of grams in here, and then you're going to use this to deliver 100 milliliters. Okay? How to make a solution with a graduated pipette. Okay? Then, how to cause precipitate and collect it. Okay, that's going to be the fourth part of your procedure. How do I cause a precipitate and collect it? And then the last part will be determine yield. Okay? Now, my expectation is that next time, so on Monday, we'll get right into the lab and start this right away, and I'll have all of the materials there for you. Normally, we would have to create the procedure beforehand, okay? But I want to do this as efficiently as I can. I want you to be able on Monday to actually complete all of this. So you already have your marching orders. You'll have a leader, and what I'll want you to do is basically go ahead and create these solutions, mix them together, collect the precipitate, and we'll get it to a point where we can dry it, and then we can measure the amount of precipitate, and then we'll figure out the yield. When you come back from break, what we'll do is we'll sit down the following class period as groups, and we'll figure out how to write all this up. Okay? So we're going to do the actual procedure next time, and you've got enough information for you to accomplish that. So my expectation is that you'll go into lab, you'll make this solution, and you'll make this solution. You'll mix the two together. You'll collect the precipitate using a filter, okay? And you will dry it, and then we'll determine the yield. The following class period, we'll sit down as a class and figure out how to write all of this up as a procedure as a class within your teams, okay? You'll just sort of sit there and write the procedure, and I'll provide you with a form that you can use, so you don't have to just write it out on a sheet of paper. We'll have a form for this. And then once that happens, once we do that, then for every lab from now on, what I'll have you do is I'll give you a Prelab with all of the information in it, and as teams, and we can change teams. I'll give everybody a chance to be a team leader. But we'll change teams, and from then on, we'll create the procedure before we actually go into the lab, because what we really want to do is be able to get into the lab and have a written set of instructions in front of us that I follow step by step by step by step by step. But I think for this first one, it's going to be easier to accomplish it this way, since you already have a good idea of what we're going to do. And this way I can kind of instruct how you need to write these things up. I will also create for you the conclusion for this write-up, okay? This will be another conclusion where I'm not going to ask you to write this up, but I'm going to provide you with a model of how you might write this up for you to use in subsequent laboratories. Okay? Any questions about what we're going to do next Monday? Okay? So again, this is something that you might do in the real world, and this is something that a company would try to accomplish as they roll out a particular type of product. Okay? And this is why we study chemistry.